You wash your clothes in a washing machine and then you put them in the dryer for drying. This is what you observe. You see the clothes rotating at a very high speed. And then they dry. Which technique do you think is used here? For the drying of clothes in the dryer, we use the technique of centrifugation. Centrifugation is the technique in which we separate the lighter constituents from heavier constituents by rapid rotation. In the dryer, the clothes are heavy, the water droplets are light. So as they are rotated at a very high speed, the water droplets, they float on the top, and the dry clothes, they are settled at the bottom. So in the dryer, we use centrifugation. Now we have to separate the colored dye from black ink. How do we separate the colored dye from a black ink? So what do we do in this case? We take a spot of the black ink, we take this spot on a special filter paper, and we dip this filter paper in a special solvent. We leave it for some time. Observe what happens. So as you leave it for some time, you see the colored components separating out, and they take different heights on the filter paper. So this is the process of chromatography. Chromatography comes from two words. Chroma means color and tography means to write. This process involves the separation of colored components of a mixture by the adsorption over a suitable adsorbing material. In this case, our adsorbing material is a special filter paper that we take. So we make a spot of the black ink, we dip it in a special solvent. So with time, we see that the colored constituents of the ink, they separate out. As they are adsorbed on the filter paper, that is, they take up the spaces on the surface of the filter paper, they are separated out. And this is the process of chromatography. We want pure water from salt water solution. Which technique do we use here? We know salt water solution is a homogeneous mixture. This is a homogeneous mixture and we need to collect the pure water. So in this case, we use the technique of distillation. What do we do in this case? We take the salt water solution and heat it. The liquid, that is water in this case, changes into the gaseous state. In the cooling jacket, it is condensed and we collect it in the beaker. So this is how it takes place. As we heat the salt solution, the water changes into the gaseous state, it condenses and is collected in the beaker. So we have separated the pure water from salt. So when we want pure water from salt water solution, we use the technique of distillation, which involves the changing of the liquid state into the gaseous state and the subsequent condensation of the gaseous form. In the last question, we wanted the pure water. But in this case, we only want salt. We do not want the pure water from the aqueous salt solution. So which technique do we use here? In this case, we know when we want only the soluble solid from the solution, we use the technique of evaporation. In the process of evaporation, the liquid, it evaporates off, it changes into the gaseous state and it leaves the soluble solid. And we get the soluble solid behind. So when we want only the soluble salt, in this case, we use the process of evaporation. Now in this case, we have chalk and salt which are dissolved in water and we want to separate the two. Now this is tricky because both chalk and salt are white in color. So now we'll use a difference, the difference of their solubilities. We know chalk powder is insoluble in water. insoluble in water. Whereas salt, this is soluble in water. So even though both are white in color, we can use the difference in their solubility to separate the two. Let's see how. So we take a chalk piece, we crush it into a powder, and this powdered form is added to water. Now we add some salt to it. We stir it. If we leave it undisturbed for some time, you see all the chalk particles, they settle at the bottom. We can decant the aqueous salt solution into another beaker. Now we heat the aqueous salt solution, the water evaporates and we get the salt. So how do we separate chalk and salt which is dissolved in water? We first separate the insoluble chalk particles. So we know the insoluble solid in this case is chalk. So by using sedimentation, we allow the chalk particles to settle at the bottom, and by decantation, we decant the pure aqueous salt solution into another beaker. Instead of using sedimentation for separating the chalk particles, we can also use filtration. When we use filtration, we get the chalk particles on the filter paper. By using sedimentation or gravitation or by filtration, we can separate the insoluble chalk particles from the salt solution. So the next stage involves the separation of salt. We know that salt and water, it is a homogeneous mixture. So for that, we use evaporation. So the soluble salt is left behind and the water evaporates. So we started with chalk powder and salt dissolved in water. We first separated the insoluble chalk particles using sedimentation or filtration, and then we separated the salt from water using evaporation. Now, how do we separate oil from water? You must have seen that oil and water, they form a heterogeneous mixture. That is, the two liquids are immiscible. They do not completely mix with each other. So for such immiscible liquids, we use a special apparatus which is known as a separating funnel. In a separating funnel, we mix the two, water and oil. We leave it undisturbed for some time. The heavier water settles at the bottom. The lighter oil floats on the top. And by opening this knob, we can separate the two liquids. So whenever we have two immiscible liquids, we can use a separating funnel. Now, in a solution, we have two liquids A and B, and we are given their boiling points. We are given that the boiling point of A is 154 degrees Celsius and that of B is 196 degrees Celsius. Also, it says that it forms a homogeneous solution. So how do we separate liquid A and liquid B? When we have homogeneous solution of two liquids, we have two techniques, that is distillation and fractional distillation. Let's see how they work. So first we have distillation. We have two liquids. They form a homogeneous solution. As we heat it, the liquid with the lower boiling point changes into the gaseous state. It condenses in the cooling jacket and is collected in another beaker. So by distillation, we can separate the two liquids when their boiling point is greater than 30 degrees Celsius. But when the boiling point difference is less than 30 degrees Celsius, we use fractional distillation. In this case, we invert a fractionating column with separating units on top of this vessel. Now, as we heat it, the liquid with the lower boiling point changes into the gaseous state, condenses and is collected. But at times, the liquid with the higher boiling point also changes into the gaseous state. It strikes the separating units and falls back into the vessel. So when the boiling point difference is less than 30 degrees Celsius and we have to separate the two liquids, we use a fractionating column, and this process is known as fractional distillation. So now distillation is used when the boiling point difference is greater than 30 degrees Celsius. Fractional distillation is used when the boiling point difference is less than 30 degrees Celsius. Let's revisit our question. We are given the two boiling points. Let's see the difference of the two. So liquid B has 196 degrees Celsius and that of A is 154. So when we see the difference, what do you observe? You see that the boiling point difference is greater than 30 degrees Celsius. So which technique do we use here? We use distillation. Now you had a jar containing sand and you accidentally dropped some iron filings into it. How do you separate the iron filings from sand? We know there are some substances like iron, cobalt and nickel. They possess magnetic characteristics. So we use a magnet. We bring a magnet to the sand containing iron filings. All the iron filings get attached to the magnet, and this is how we separate the magnetic substance, that is iron filings, from sand. These are some separation techniques for the different mixtures that we have.